Okay, so today, my algebra doing friends, we're looking at 10.3, solving algebra, solving absolute value equations. And so we're going to do a few out of your book that you can just think about, and those, just thinking about it kind of gives you the idea of what the strategy is that they're going to have. I've written out a real long strategy, as you might see, to make sure that everyone can kind of see every single point. But when you start thinking about it, it's not really that difficult. And so I'm thinking about the absolute value of something, and the answer is equal to 7. So these are the absolute value symbols. Remember absolute value? I don't know if you guys do, so let me give you some examples. Like the absolute value of 8 is equal to 8. And the absolute value of negative 8 is also equal to 8. Absolute value is a distance, and so it's always positive, and it's asking, basically this is asking the distance from 0 is what it's asking. So on the number line, how far am I from 0? And if you're over here at 8, then you can count, well, you're 8 away. Well, if you're over here at negative 8 and you count, well, you're 8 away. And so here it's asking you the absolute value of what is equal to 7. And so I hear some of you saying 7. And so you're right. That's one answer, right? 7 is a good answer. So one of my answers is x equals 7. Is there any other answer that would work? You take the absolute value of it and you get 7. And so you're right, negative 7. And so the absolute value of negative 7 is also equal to 7. Is there any other answers? Nope, that's it. There's only two things that when I take the absolute value of it, I get 7. And those two things are 7 and negative 7. This kind of almost looks like a, well, I don't even know what it looks like. Not a number 7 though, to me anyway. So now so that's the answer to problem 2. And all we did, right, was think about it. What could I put in there so I get this? So I want to think about this too. Absolute value of what is equal to negative 4? So I hear a lot of people saying to me, well, that can't be. Because remember how absolute value was defined. It was distance, right? And your distance can't be negative. And so the absolute value of 8 was positive 8. The absolute value of negative 8 was positive 8. The absolute value of anything is equal to some positive value. And so this is no solution. And we didn't really use any strategy other than thinking about it. What does absolute value mean? What could I put in there? And so now we're gonna do a think about it on this problem too. Number 30 out of your textbook. The absolute value of 8 minus 6x equals 0. And so what do you think would be possible for our value for x? So in this thought, I'm thinking the absolute value of what equals 0. That's what I'm starting off with, is the absolute value of what equals 0. And I agree, 0. Is there two things that can be in there or just one thing? Yeah, there's just one answer to this, right? And so that must mean that the stuff in here must be the same as 0, right? In order for the absolute value of 0 to equal 0. So whatever this is needs to be equal to 0 so that when I take the absolute value of it, I get 0. So this means that 8 minus 6x must be equal to 0. And we just did our first conversion of it, right? We changed it from an absolute value problem. Over here we sort of guessed, right? But here we used our reasoning, our critical thinking, to turn it into a linear equation that we can solve. And so, and now we can add 6x, you got it linear, get them separated, right? Take away 8, whichever one you want to do. I'm going to add 6x. It's your choice, whichever one you want to do. So when the dust clears, I don't have quite enough room here. I get 8 equals 6x, and I'm going to divide by 6. And so I get x equals 8 over 6, which is the same as 4 over 3. And I'm sorry, I didn't have enough room there. And so I kind of almost had to write up the side of the paper. And if you go and you check that answer to see if it's right. Now this calculator right here has absolute value on it. So you actually can use the absolute value key on your calculator. And so depending on your calculator, you might find that absolute value key in a different spot. Mine is that word right there, ABS. And if your calculator is in complex mode, and it might be from coming out of chapter 8, the way that it is, then what you want to do is I don't think it'll work if it's in complex mode. I might be wrong on that depending on your calculator. I don't think this one will work. So you have to go to menu. So I hit the menu button, and then I'm not in complex mode. Number 2 is complex mode, see the I, but I'm in this just regular arithmetic mode. And so I had my calculator in number 2 in complex mode. See how it says complex down here. Back when we were in chapter 8 there for a while in chapter 9. And now I'm just in regular calculating mode. Okay, so I made sure that my calculator was in a good mode because I want it to be able to do absolute value. The absolute value is that button right there, ABS. And so I'm going to hit Shift and then that ABS button, and you see it puts the absolute value on my screen. And then I'm going to check 4 over 3. So right in here I have 8 minus 6, and then I'm going to have times, and then the fraction 4 over 3. And then boom, 0. And that's what I was expecting, right? If it was equal to 0, then I know that I have a good answer. Okay, and we reasoned that there could be only one answer to this because the only value that when I take the absolute value of it, I get 0 is 0. Okay, so that's what this strategy is going to play on, okay? It's going to say, what do you have in here? And if it equals 7, well, there could be 2. And if it equals a negative, well, there can't be any. And if it equals 0, there could only be 1, right? So that's what we're going to be thinking. And so, and this is just me saying, remember what absolute value was, and I did that here. Remember what absolute value was. I probably should have that up here, right? It's the distance from 0. So we did that. Strategy for solving equations that involve absolute value. You have to have the absolute value isolated on one side of the equation all by itself. So this already had that. And this did, and this did. So I didn't have to worry about that. And then I paused, and they're saying pause and look at what you have. And what we did here is we paused and reasoned out what we have. And they say there are 4 cases, and we did 3 of those cases here. The absolute value equals a negative number. That's the one that we did in number 6. Boom, there's no solution. So it doesn't matter what negative number you have on the other side, there's no solution. It also does not matter what you have in here. So things like absolute value of x plus 1 equals negative 6, no solution. The absolute value of 3x plus 2 equals negative 14 over 3, no solution, right? And so it doesn't really matter what's in here, inside here. And so it only matters that there's a negative on the other side. Now, warning, this is not that. Absolute value of x plus 1 minus 7 equals negative 6. I wouldn't say, boom, there's no solution, because the absolute value is not all by itself on one side of the equation. And when I get it by itself on one side of the equation, I don't have a negative on the other side, I have a positive. So you can't just, say, oh, there's absolute value, let me look, and boom, you have to make sure that it's by itself. So the absolute value of some value equals 0. This was number 30. And so you just have to solve a equals 0. And that's exactly what we reasoned out, right? Whatever you have in here, solve equals 0. And boom, you'll find the answer. The absolute value equals a positive number. Then there's going to be 2 cases for the answer. When a equals the negative of that positive number, you have to solve, and when a equals the positive number. So if I have the absolute value of x plus 3 equals 7, then there's going to be two solutions to this. There's going to be when x plus 3, that's my a, equals negative 7, solve, 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 and when x plus 3 equals 7, solve, 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 the negative of that positive number. So these are the two cases and are going to give me two different answers that will solve this problem. And we'll do a few, don't worry. I'm just giving you examples of what they're saying there as we go. Getting ahead of myself is more really what's going on, huh? And so here is the absolute value equals an absolute value. And there are actually two cases on it as well. It's not as easy to reason out, but if you wanted to put some x's and some numbers in there, you could start reasoning it out, or x's in both sides and start reasoning it out. But it's there's two cases. When one of the cases is when a equals the opposite of b, and the other case is when a equals b. And you can certainly see that that would be true. When a and b are equal to each other, then they're either both positive or both negative, and you wouldn't need the absolute value at that point, right? And so for them to be equivalent to one another. And if they're opposite of one another, then when something's negative, when you take the absolute value, it's positive, so they would be equal to one another. Just looking at some numbers, right? That just so that you can kind of see with just numbers, the absolute value of 3 equals the absolute value of 3, right? And certainly you know that's true. And the absolute value of negative 3 equals the absolute value of negative 3. And the absolute value of 3 equals the absolute value of negative 3. So this is the case where they're equal. So it's case 2. And this is case 1, when they're opposite of one another, and so with numbers. And so anyway, so that's kind of the story. We're going to give a try to solving some. Hot diggity dog, you say. These are not particularly hard, but they take practice. And what happens is that people haven't practiced and they think I'll just ignore the absolute value. And that doesn't work at all. So I can't apply any of my stories, any of my principles here, can't apply any of these because I haven't done step number 1, which is isolate the absolute value, get it all by itself. It's not all by itself on one side of the equation on this problem because of the -4. And so what I would like to do is I would like to get it by itself by adding 4. So when I add 4, I'm going to get the absolute value of 5x minus 3 equals 7. And now I can pause and either use logic and think about what I have, or I can just use the rule. And so the rule says if it's positive, which it is, so I'm asking right now, is it positive? Is it negative? If it's 0, is it another absolute value? Right? Those are the 4 cases. Once you get your absolute value isolated, and those 4 cases tell you what to do. And so mine's positive. And so since it's positive, they say that there's going to be 2 answers. When this inside, right in here, the inside equals 7, right? Because the absolute value of 7 equals 7. And when the inside, the other answer is when the inside equals -7, because the absolute value of -7 also equals 7. So you get these 2 cases, 5x minus 3 equals -7, or 5x minus 3 equals +7. And then you just have to solve that. So this is add 3, it's linear. So I turned it into linear. It was absolute value, and I used the principle to turn it into linear. So I got one answer, -4/5. And my other answer, adding 3, 5x equals 10, dividing by 5, x is 2. And this is not a must check. We were talking about must checks versus it's a good idea to check. This is it's a good idea to check. Most people don't check. and then they get the wrong answer and they're upset about it. And so you need to check if you want to get the right answer, because everybody makes mistakes. When you make a mistake, it is best to be nice about it and try to see if the mistake can be fixed using your sweetness rather than your aggression. My grandma used to say that you would get more with sugar than with vinegar, is what she would say. And it's definitely true. People want to bend over backwards to help you when you're being kind. But the minute that you start being unkind, why would anyone want to help you? And so anyway, so there's a lesson in life, right? Okay, so I'm going to put in here -4/5 in my check, right? So this is what I'm going to check. X equals -4/5. And I want to see, does that equal, right, this side, does that equal 3? Okay, so that's what I'm going to check out. And I'm going to use my calculator. I could even go in here and edit, because I already have the absolute value on the screen from the last problem, if I wanted to. Or if you're like, no, that's crazy talk, why would I do that? I can put the absolute value in again myself. So there's absolute value, and then it's 5 times, and then it was -4/3. I changed it to 4/5. No, it was 4/5, and I'm trying to change it to 4/3. -3, and then on the outside -4. And so I put that in, and I'm hoping that equals 3, because if it does equal 3, then that tells me that -4/5 is a good answer, and there shouldn't be extraneous solutions in this. So I'm making sure. And now I want to check with x equals 2. So right here where I had x, I'm going to be putting in 2. Now there's certainly no reason, and I didn't get fully the negative erased from the previous problem, and there's certainly no reason to type this all in again, right? I can just back up and let's see here, doink, 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 2. And I wanted +2. And it does matter. And I also get 3. If you check -2, a lot of times people will say, well, shouldn't the opposites work as well because it's absolute value? Well, let's just check -2 and just see if it works. No, it shouldn't work. And it's because it's not the opposite. That's not the whole inside right there, right? The inside is 5 times that value -3. And so anyway, so here we have that 3, that's what we were checking, equals 3, and we're like, hot diggity dog, right? So both of our answers worked, and we were on a good idea to check. Okay, now that was problem 32 in your textbook. Now we're going to do problem 34 in your textbook that has a 9 in it. And so again, the absolute value is not all by itself. So in order to solve it, you got to get the absolute value by itself. So I'm going to put my whole finger on the absolute value. See why it's not by itself? It's because of the +9. So I have to take away 9. So I get the absolute value of 8 minus 7y equals -8. And this is where you pause and you look at what you have. Do I have a positive? Do I have a negative? Do I have 0? Do I have another absolute value? Because depending on what I have is what I'm going to do next. So I don't have a positive, I have a negative. And the good news is that when it's negative, if you're a person that just likes to be done really quick, it's one of those, right? Because when it's a negative, there's no solution. And then the last one that we're going to try, and then you can go and watch more videos out of your book if you like, is where here my absolute value is all by itself, and that absolute value is all by itself, and I end up actually having this scenario where the absolute value equals the absolute value. And so when you have that, the story is they are saying absolute value of A equals the absolute value of B. They say that there are two cases, right? So I have this, so this is my A, and this is my B, so to speak. And the cases, I call them case same and case opposite. So this is the first case, case opposite, when A equals negative B. And so this is going to be 5A plus 2 equals the opposite of this one, which is 4A plus 7. And then my other case, so this was case 1. It doesn't matter which one you do first. And this is case 2. Case 2 is going to give me another answer, and that's when A equals B. So this will be when 5A plus 2, that was A, equals 4A plus 7. And now it's solve, solve, solve. This is linear, so I know how to solve it. You have to distribute the negative and then get the variable on one side and the numbers on the other. This is linear, so I know how it is to solve it. It doesn't have any distributing to do. All I have to do is get the variable on one side and the numbers on the other. And then you would want to check your work. So we get 5A plus 2 equals minus 4A minus 7. And I'm going to add 4A to both sides. And I'm going to take away 2 from both sides. So when the dust clears, I get 9A equals negative 9. So one of my answers is going to be A is negative 1. And it's always a good idea to check. And so I am going to check this answer. And then my answer over here, take away 4A, take away 4A, take away 2, take away 2. When the dust clears, I get A equals 5. There's my second answer. So these are both my answer, right? This is my answer or this is my answer. They're both my answer that I want to give. And it's a good idea to check. So when I check, I hear my family discussing dinner. It makes me happy to think that there could be something to eat. Today's been a pretty lousy day. And so having food in the horizon is a good thing. Okay, so we're going to have the left side, and we want to see, does that equal, question mark, right? The right side. And I'm going to be putting in negative 1 right here. So I'm just going to use my calculator to do that. So I'm going to clear out what I had, although it was pretty close to what, it wasn't the same, but it was pretty, there was some editing could have been done there. So 5 times, and then on the other side there, I'm going to have negative 1. Plus 2. And I got it taking the absolute value for me, doing everything. So that says that's 3. Actually, the inside there, I'm going to write it what it was. It was the absolute value of negative 3. When I put in negative 1 here, because times 5 is negative 5 plus 2 is negative 3. And the absolute value of negative 3 is 3. And the right-hand side, I'm going to put in also negative 1. And when I do that, when I put in negative 1 there, I get 4 times negative 1 is negative 4, plus 7 is, so that side actually is the absolute value of 3, which is equal to 3. A coincidence when I gave the crazy examples about the 3's down here. Probably not really a coincidence, probably my mind remembering from last semester, but it could have been anything. So this could have been negative 5, absolute value of negative 5 and the absolute value of 5, and it still would have been true. I just want to see, does the right side equal the left? And it did, so this is a good answer. So now I want to check out 4A is 5. So when you put in 5, you get 25 plus 2 is 27. The absolute value of 27 equals, you put in 5 here, you get the absolute value of 27. And see how they're equal to one another now. And 27 equals 27. Now I don't get to choose whether or not they're positive, both of them. That's going to work itself out in the problem. They're either going to both be positive or both be negative here. And so this means that A is 5 is a good answer. Now I have to admit that I haven't done every single problem type. I've done nearly every single problem type. I have actually done every single problem type from the new step to this, from here to here, but I haven't done every problem type when you get here. And so since I do have a little bit of time, I'm gonna try one of those. I know that there's probably one in your textbook, but I'm just gonna make one up. So this is my example, and I'm just making it up on the back of my page here because I know that there's problems in the book like this, and I had it in the lab, and then I had myself running around and helping you. So if I have this, x plus 1 equals the absolute value of x minus 2, pretend. Then this is one of those that just like we just did, that has two cases. And so we're gonna solve both of those. What did I? Oh, I turned it over. Oh my gosh, I was gonna show you how that we were gonna solve both of those cases. It's the same scenario as this, right? So we're gonna have our case 1 and our case 2. So this is like our A, and this is our B, and we have our case 1. X plus 1 equals the opposite, x minus 2, right? The opposite of B, right? It was A equals the opposite of B, and B was x minus 2. So when I solve this, this is x plus 1 equals negative x plus 2. You distribute the negative. Then you add the x to the other side to get them on one side. So you might be thinking, no, this is exactly the same as the one we just did. And I'm going to show you that it's a little bit different. That part of it was exactly the same, but this part of it on case 2, I don't know, when I wrote that in cursive like that, it made me think of Smith's cookies, and I don't know why, but those sound really good. I mean, I really feel like we're suffering here without all of our things, right? X plus 1 equals x minus 2. So if I was to solve this, the first thing is the x's would drop right out on me, right? And when the x's drop out on me like that, then I'm going to be getting 1 equals negative 2. And that's not true. 1 doesn't equal negative 2. And so this doesn't provide any additional solutions. There was already one solution, but there's no solution from case 2. So it doesn't mean there's no solution to this. It means there's no more solutions. So this is not going to provide another solution. So I'm just going to put an X there. I don't want to write the word no solution and have you think that there is no solution. There is one. There's one solution right here. And you could check that that solution works, right? If you put in half, then this is half plus 1 is 1.5. The absolute value of 1.5 is 1.5. If you put in half here and take away 2, you get negative 1.5. And the absolute value of negative 1.5 is positive 1.5. And 1.5 equals 1.5. So it certainly does work. Okay, there's another type that you could have there. You're like, no, not another type. Are you kidding me? How many types can there be? And so there's another one. So let me show you the other type that could certainly happen. And so that other type is something like this. They try to hide it. And I'm trying to hide it while making it up at the same time. Has that ever happened to you? Okay, so you might not feel like it's very well hidden, but okay. So this is the A and the B, and there are two cases. So if I was just kind of blindly going, A equals negative B is one of the cases. So that's 2x minus 3 equals negative of 3 minus 2x. So this is 2x minus 3 equals, and you would distribute, negative 3 plus 2x. And then all of a sudden, instead of having that situation where we had here, where it's never true, we have something that's always true, right? If I was to keep going, see how both sides are exactly equal, and if I was to keep going, I'm usually too lazy to keep going, I would end up with, if I kept going, 0 equals 0, right? But when both sides are equal to one another, you don't have to keep going and solve it more. When both sides are exactly equal to one another, have exactly the same pieces like that, do you guys remember? It's all real numbers is the solution. This says everything is a solution. And so there is no reason to go over here and do case 2. Because if case 2 gave you no more solutions, well, everything was already a solution. Or if case 2 gave you one more solution, so let's say that it said that 6 is the solution. Well, 6 is already the solution included in this. So you're not going to get more solutions. This can't take away. So there's absolutely no reason, once you get all real numbers, to do this. No reason to continue, right? We already know that everything is a solution. Now, if you ended up with this first, there would be a reason to continue. This says, I'm not giving you any solution. So what does this give me? I need to go find it, right? But this is not going to add to or take away from what I already have. So this one's all real numbers. So those are the two types of example that I had left for you in lab. I think that you might see one of those in lab. And I know that if you do the homework, you'll see both of them. Okay, my friends, I'll see you in the next video. Bye-bye.